Hey guys, we're headed to the North Shore again. We got another trouble call for a residential well pump. This is a little 5 horsepower well pump with a VFD, variable frequency drive, running it. The drive apparently, according to customers, shows high heat sink temp and is faulted and the well's not running. They use this well for irrigation purposes, keeping their landscaping nice and green. It's an older drive, a Yaskawa. It's been there for a while. We didn't do the original install. It's a NEMA 1 type, which means it's not sealed. It's just for indoor rated. It's just to keep fingers out of it, essentially. It's not waterproof or weatherproof in any way, not even drip proof. We find here that the NEMA 1 equipment gets a lot of bugs in it, especially if it's in a shed or underneath a house. We have a real problem with geckos getting into the equipment here in Hawaii. So I've seen it before where that's the problem. You get a bunch of gecko carcasses inside an old variable frequency drive and it messes with the fan's ability to cool by just jamming them up, or their carcasses cause little shorts inside the panel or inside the drive. So yeah, we'll see when we get there how bad it is. It is an old drive too. Perhaps it's just finally reached the end of its service life there and its main chip is overheating. But yeah, very likely there's just a dead gecko in a fan and we'll pop it out and the whole thing will spring back to life. Yeah, we'll just head on down to the North Shore and see what we can figure out. Oh, here's our well drive VFD. Yaskawa P7, fault trace is OH1. You can see the customer has applied an aftermarket kit to keep the geckos out with some screen and a duct tape. Doesn't look like it's working too well though. You can see all the dust and dirt and gecko poop all collected on the exhaust fan area. Alright, let's try resetting it and see how long it runs. There we go. Ooh, it immediately faults. Interesting. Right as it starts, it faults. I think we gotta open this thing up and look a little closer. We're gonna open this thing up and take a closer look. It's faulting right as it wakes up, right as it tries to run on a high heat. I think it might be toast, but we'll look on the inside and see what we can see. First thing we'll do, I'll isolate power. It's pretty bad. I mean, you can see there's a gecko right there. You can see him in there. He's just hanging out. There he is. Hey, buddy. And that's just the front wiring termination area. Get out of there, you. Come on. Get out of there. And then they're definitely all in the back too. I want to see if I can spin these fans. Let's see if we can get in here. That fan spins. And that fan spins. So they're not jammed up. There's one more thing I could try, and that would be to isolate the motor from the drive, just to be sure. Just to be sure that the problem is in the drive and not in the motor. Because I've seen sometimes where there's dead short in the motor, and that could be it. If it starts working all of a sudden, I'll get my megometer out and do a megome test. So we got red, blue, red, black, yellow. Actually red, blue, black. Okay, so there's our 3 leads now to our 3-phase 5-horse motor. Disconnected. That's all safe. Let's fire it up. See if it still overheats with no load. Yep. Heatsink max temp. OH1. So even with no load connected, it's faulting out. I think we're ready to change out the drive and get a whole new drive. Picture this nameplate. And we know what size pump it's for. And then we can just leave the power off. We don't need to reconnect this because she's dead. Alright. That is a dead drive. Here's another simple Hawaiian wellhead. There's a cement casing, well seal, the power going down, our water meter, tees down into the ground, little test port here, and from there it runs over into the pressure tank at the pump house. Looks like they got a little leak here. Pretty substantial. Where's it coming from? Well, we should figure out where this leak's coming from. So what looked like a little leak is actually pretty substantial. This is our well discharge. Comes down, turns, goes underground right here, and tees off over to the pressure tank inside of the pump house, and also tees this way to the distribution. It 45s down, and then it 45s again right there, and that's where the leak happened. Looks like the pipe just cracked, or the fitting, hard to tell. And then it runs along this way. Then they've got this mystery 1-inch valve, or 1-inch line. It's just capped off here, but it's not glued, and the valve's shut. We can turn that on. There's pressure on the other side, and then before it goes too far, it just tees up to this little service hose bib here. It's got that blue primer on it, so I know I didn't do it. And it looks like PVC was just under tension when it was installed, and the tension just caused it to crack later. PVC will crack over time if it's got any tension on it at all. So it's got to be resting in place, otherwise it'll find the weakest point in its system there and just crack right open. Okay, so we got a plan, 1.5 PVC. So yeah, we'll be back to make a repair as well, it looks like, and give them a proposal for a brand new drive.